Hello everyone and welcome back to R&M LAB GH. Today we are building a rather special type of measuring device, as you read from the title, the Ultrasonic Meter. To create this very interesting project, we will be using some new components that we haven't covered yet. This system uses the exact same technique that bats use to navigate and perceive distances, called echolocation. Let me better explain how the ultrasonic sensor works. The sensor first sends out an ultrasound wave, which is a frequency that the human ear cannot perceive. The sound wave travels, hits an object, and bounces back. The second part of the sensor then receives this returning ultrasound wave, or the echo. The system calculates the time it took for the wave to complete the round trip. This time is processed by Arduino and converted into a measurement that we display on the screen in centimeters. Essentially, much like a radar, the bat does not see with its eyes but uses ultrasounds. It sends out a wave and captures its return to calculate the actual distance. It is truly spectacular to see that the technology we have available today has always existed and exists naturally. Your reflection on nature is perfection. The best camera in the world is the human eye, and yet, despite all the advanced technology, we are still unable to fully replace it. This is just an example to compare what has existed in nature since the beginning with our own inventions. Project components. For this project, we will be using our Arduino Mini, or the equivalent you are using, the breadboard and jumper wires, 2 LEDs, one red and one green, one buzzer, one external button, an LCD 16-sword display with an I2C interface, and the two main new components. The HC-SR4 ultrasonic sensor, our Rotary Encoder. As always, I have prepared for you the intuitive wiring diagram, which you can find in the description below. By following the diagram in this video, it will be very easy to assemble everything. Alright, the hardware assembly is complete. Now, let's move over to the computer. As always, we connect the USB cable between our Arduino and the computer. We will now upload the code which, as usual, you will find available in the description along with all the other documentation. Crucially, always remember to select the correct Arduino board and the appropriate communication port in your IDE. Once the code compilation is finished and the sketch is uploaded to the microcontroller, we will be ready for the most fun part, testing our ultrasonic meter. I will walk you through, step by step, to explain all the features I have included in the code. The simple meter mode on demand measurement, the target setting mode using the Rotary Encoder, the verification mode with LED and buzzer feedback. Let's go! Now we will see how to simply measure a distance by pressing the button in simple meter mode. With every press, it measures the distance in real time. The precision is quite good. Obviously, there is a small percentage of error, but it is very limited. Now we will see various measurements by moving the object I prepared for the test. As you will notice, the response is very fast and we immediately see the measured value in centimeters on the display. We are also positioning a ruler to verify that the measurement is correct. This test allows us to see how precise the project actually is and verify its correct operation. Verification mode target. Now let's switch to the other mode, where we can set a specific target distance using the Rotary Encoder. Then, by pressing the button, we can verify if an object is at that exact target distance. For example, if we set 4 cm and press the button, we get a result. If the object is too far, the red LED will light up. If the object is too close, it will also signal an error with the red LED. You can still monitor the variation by looking at the display. The moment the object is at the correct distance, the green LED will light up, confirming the measurement we set. This system can be used to test correct sequential measurements without wasting time. It is a very effective solution for anyone needing quick and precise verification. Thank you all for watching this video. I hope you found it interesting and useful. Please subscribe to the channel, leave a like and activate the notification bell so you don't miss the next projects. I wish you all well, thank you again, and see you in the next video. Bye.